Okay, let's give you guys some more practice. So here I've got a graph of y equals 1 over x. Now, if I were to draw a tangent at x equals 1 here, if I were to draw a tangent, it would look something like this. Not to scale here. And then if I were to draw another tangent at x equals 2 here, it would look, I don't know, it would look something like this. I don't know, something like this. And then I'm going to draw a tangent at x equals 3 here. You see, which one will give me the biggest area? So if I were to draw a tangent at x equals 1, it would give me something like this. Now, so here I've got an area here. Okay, well, which one would give me the biggest area? So for x equals 1, it would give me this area here. Okay, now if I were to draw a tangent at x equals 2, it would look something like this. I don't know, something like this. And then work out the area here. Which one would give me the biggest area? Will it when x equals 1, or when x equals 2, or when x equals 3? So if I were to draw a tangent at x equals 3, I don't know, it would look something like this. And then this area here. Which one would give me the biggest area? Okay, so somehow find a way of working this out. Which one would give me the biggest area? The area under the tangent when x equals 1. So well, here, here, and here. So you've got a triangle here. You've got a triangle somewhere here, and then you've got another triangle somewhere here. Which triangle will give me the biggest area? So press pause and have a go. Okay, so to do this here, well, if you were to draw a tangent somewhere, well, if you were to draw a tangent at x equals 1, you need to find out the equation of this straight line. And once you've got the equation of this straight line, then you can work out this point, and then you can work out this point here. And then all you have to do is get the height times the width here, and then that will give you the rectangle, and then cut it in half. Then that will give you the area of the triangle here. Okay, so the first thing to do is to find out you want the equation of this line here. But in order for you to get this equation, you need to know the gradient of this line here. And the way you find the gradient is to differentiate this. Okay, so the first thing to do is to find the gradient. Differentiate that. So hang on. So you start with y equals 1 over x, but rewrite it as this, and then differentiate it, and then it will, remember, when you differentiate this, it goes here, and then x to the minus 2. And then that will simplify to this. Try to ingrain this inside your mind. When you differentiate this, it will give you this. Try to ingrain this inside your head. Okay, memorize it. So differentiate this, it will give you this. Okay, so now you see when x equals 1 here, don't forget this point here. This point here is, well, this is your x here, and remember, because it's a graph of 1 over x, at this point here, you see, when you put 1 into here, it would be 1 over 1. So this point here is 1 and comma 1. Okay, so this point here is 1 comma 1 in effect. Okay, so here we want to find out the equation of this line. Don't forget, we know the gradient at this point, which is this point here. Now at x equals 1, we can put this into here. Remember, this thing here represents a gradient. Because we want to know the gradient at this point here, the gradient will be this. So we put the 1 into this x here. So the gradient, don't forget this here. This is our equation of a straight line. Now this here is the gradient. You see, when you put 1 into the gradient, it will give you this. Okay, yeah. So put 1 into here just to find the gradient. So here we've got the gradient here. That's all we've got so far. And at 1 comma 1. So now we are using, we know the gradient at this point, and we also know that the straight line here passes through this particular point, which is 1, 1. So because we know it passes through one particular point, we've got the gradient already. The gradient is this here. Okay, the gradient is this here, and we know that it crosses 1, 1. So this is your y, this is your x here. So put this into the x, and then put the y into the y here, just so that we can find out the intercept. Okay, so blah blah blah. The intercept equals 2. Now, because we know the intercept equals 2, we can hang on. So, oops, sorry, hang on. So so we know the gradient here. Okay, we know the gradient, and we know the intercept is 2. So we in effect know the equation of that straight line, which is given by this. Okay, and once we know the equation, we can find out this point here. Okay, so hang on. So remember that the equation of our straight line is given by this here. Now, once we've got the equation, we can simply find this point out. Find out this point. Sorry. So at this point here, y will be 0. The up and down at this point here will be 0. So you put 0 into the y and then work backwards to find out x. So this point here is 2. Okay, and don't forget the equation. This is our equation here. If you put 0, you see this bit here is when x equals 0. If you put 0 into our equation, it will give you this point here, which happens to be 2. And by the way, you can tell that just by knowing the equation. This here is our intercept. So this is 2, and this here is 4. So the area would be the height, which is 2, not to scale here, by the way. The height is 2, this here is 4. Okay, so wait there. So the area is the height, 2 times 2, that will give you the rectangle, and then cut it in half, divided by 2. So the area here is 2. So when you draw a tangent at x equals 1, the area here will be 2. Okay, so now let's try and do it for when x equals 2. So hang on. So remember, for x, the tangent at x equals 1, the area is 2. Okay, when x equals 1, the area equals 2. Now we're gonna try it for this one here. Okay, so hang on. So remember, the area is 2. So now we've got to try it for x equals 2. So we draw a tangent at x equals 2, and again we need to know the equation of this line. We've got a formula for the gradient. Well, we need to know the gradient. So the gradient, remember that our gradient, which is dy by dx, equals minus 1 over x squared. So this here is our gradient here. Because we are now at x equals 2, we've got to put the 2 into this x here, just so that we can find the gradient at this point here. Well, the gradient would be this. So put 2 into here, and then that will give us the gradient. Now we know the gradient at this point here. We know the gradient, and we also know that it crosses 2, a half. Okay, because don't forget, this purple line here is y equals 1 over x. And then if you want to know this, then you put this into this y equals blah blah, and then it would take you to the y point here. My point is that this point here, this is our x, this here is our y. Okay, so at 2, a half. So you put it. So this just put everything into our equation here. So this is our x, and this here is our half. Put it into here. So half here, blah blah blah. This is our gradient. X, remember, x is this thing here. Yeah, just put in there. Find the intercept. So once you've got your intercept, then you've got your equation. So this is our equation now. Okay, so again, blah blah blah. Well, once you have your equation, you can work out this point here. You can work out this point here. this by the way is our intercept. So this here is 1, and then well, follow through from when y equals 0, blah 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 here, x equals 4. So this point here is 4. So this point here is 4. This point here is 1. Okay. So now if you want to know the area, it would be 1 times 4 and then divided by 2, which is 2. Okay. So the area here is also 2. Okay. So the area is also 2. Okay. Now we've got to try it for x equals 3. Now same process. So blah blah blah. I'm just going to scan through this. It will be the same process. Your aim is to find out the equation of this line, and then later on find out this point and find out this point. Then get the height times this here, and then divided by 2. That will give you the area. And then I'm just going to scan through this. So blah 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 here, blah blah blah, blah blah blah. So this here is our equation here, and then once you've got your equation, then this turns out to be 6. This turns out to be 2 over 3. Get this times this. That will give you the rectangle divided by 2, and it turns out that the area is also 2. So the answer to the original question. Hang on. The answer to the original question. Which is the biggest triangle? This one here, or this one here? I think, yeah, or this one here, or this one here. Well, it turns out that they're all the same. And as it turns out, it doesn't matter. Even if you're here, the area underneath here is still 2. Even if you're 2 point blah 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 whatever over here, the area is still 2. Even if you're over here, the area is still 2. Even if you're right here, then the area is still 2. In the next video, I will show you why it's always 2. Okay? Hang on. Yeah, sorry. I'm just going to scan through this. So that, well, I don't know if this is useful. I'm just going to scan through it. So if you don't understand something, you can pause it. Okay? Almost there. Okay, I think that's it. Okay.